mainly today we'll be covering how LiDAR 360 oriented 3D geospatial data being processed and used in real world application through this workshop. Initially, this was planned to be a physical workshop, but due to unfortunate events regarding this dengue outbreak and university needs to be held on online and things like that. We had to move this into a online session, and I think I also prefer it is much more productive. This was held in a lab with hands-on session as with necessary accessory. But now you can we have to do this session online. But the plus point is many of the majority of the participants can join and learn what this software is about. And today we will be particularly focusing on LiDAR 360 and how 3D geospatial data we used in various applications. Uh, Starting from 3D point cloud processing and what is the LiDAR and fundamentals about LiDAR and why we need 3D geospatial data and why LiDAR 360 being, is kind of prominent in this domain. And with that, we need to our, we move to our uh, hands-on session with live demonstration of software applications. So I'm Thilosha Nipunajith. I currently work as the spatial data systems manager at SULECO, which happened to be one of the leading geospatial firms in Sri Lanka. So let's start with basic. What is LiDAR? And actually, LiDAR stands for light detection and ranging, and that's why we call LiDAR. And it's about in its what how do you say the most thing about LiDAR is it's like it's an active remote sensing technology. And as any other remote sensing technology, it also uses pulses of radiation to detect distances and take measurements. So the thing with LiDAR is it's it's helpful for calculate three-dimensional point cloud data set. And when it comes to real world application, it's much useful in vegetation penetration. And when we require to penetrate vegetation data or any other data, we can adjust parameters and use LiDAR technology to do that. And depends on the density of point cloud and depends on the density of point cloud, we can uh, move into our several requirements. Like for suppose, if you want to do a classification regarding vegetation using optical satellite imagery. So suppose if you're using optical satellite imagery or drone satellite imagery, doing that kind of classification using imagery alone requires some kind of individual input, and it requires some kind of uh, relying on basically on neighborhood data of pixels, things like that heavily. But when it comes to doing this kind of classification using 3D data, just by deriving CHM for each height model, you might getting these things more understandably once we start a practical session. We can do it really accurate. So that's why this LiDAR is required for, mainly to provide accurate 3D geospatial data. But when it comes to any other classification or any other segmentation done using 3D geospatial data might come more handy rather than using 2D geospatial data for this. So that there's that. And when it comes to accuracy, we are talking about centimeter level accuracy here. And also there's a high point density, and it can be bit from 100 points to 2 million points per second can be captured through LiDAR sensors. And we change this derivation according to our requirements. And range goes uh, from up to 6 kilometers. I think with new sensors, it can be covered in higher. And also based on the platform that we using to implement our LiDAR sensor, we can cover large areas. So it's really quite worth in real world industrial applications, because one of the most problematic things when it comes to this kind of industries is consume of time and money. So there's that. So let's move forward. So here's a comparison with LiDAR with other surveying methods. So these other surveying methods you might have been quite familiar with one way or another. So suppose some of you are from engineering background, and some of can be from geospatial background, and some of can be any other related background. But still, you might have seen at least a survey doing surveying work on a road or construction project. So here are some of the comparisons when it comes to other, let's say, conventional surveying method, but still these are not actually conventional, but still we are using TS for high accurate data, and we are still using photogrammetric data. It's not like LiDAR is the next level thing and LiDAR is can do everything. It's not like that. LiDAR, of course, has limitations, but compared to technologies, some of the technologies that we mentioned here, it have some advantages, and it also have limitations as well. But since we are talking about 3D geospatial data, it's quite uh, LiDAR is quite prominent, and it comes in handy in very ways. And when it comes to accuracy, within with the large point cloud data, we can have this kind of accuracy is quite impressive, and it is also impressive for other surveying and geospatial data collected methods as well. And when it comes to textured 3D model compared to deriving this 3D model using photogrammetric data. We directly using LiDAR point cloud data, we can have a dense 3D point cloud. And also, unlike other mentioned techniques here, we can't penetrate vegetation like that with you know other survey techniques here. But in photogrammetry we can, but it requires, of course, good lighting conditions. And also, one other thing is with the range and point density, it can cover point frequency and range. It can cover large area in a small required time. And when it comes to photogrammetry, it quite be quite like it can be quite mid level, it's mid range, and you can say it's moderate. And also, when it comes to total station and GNSS survey, it's like it's big. We are working from one network to the other, one point to another, so it takes time, and the coverage is very slow. And LiDAR can be worked in both day and night, and also uh, 3D when it comes to 3D data extraction, unlike any other technique, we can move to LiDAR. So let's move forward. So here are some of the applications of LiDAR technology. Of course, topographic survey is whatever you deal with the surveying technology. Sorry. Sorry for that technical issue. So when it comes to applications of LiDAR, there can be, whenever you using survey application, whether it's for construction, whether it's for archaeology, whether it's for agriculture, whether it's for like road construction, you name it. When it comes to covering the 3D domain, you can more rely on LiDAR. So that's one of the things, when it comes to deriving high accurate terrain mapping and deriving, elevation model, terrain models, and everything that you derive through, whether it's you name it satellite imagery, you name it GNSS data, you name it like, raster, whatever the raster data that you'll be taking from, whether it is satellite imagery or drone imagery, you can use it LiDAR as well. The thing is, when it comes to most of the time, you think LiDAR is all about 3D point cloud and deriving 3D data, 3D modeling, but it's not like that. If we have a proper high densified point cloud done and that could reach within our accuracy limit, we can derive these raster data using this kind of point cloud as well. So it's quite handy because suppose if you are using suppose you are doing in a survey in a very crowded area, like suppose you are doing a city model or something like that, and then you need to understand how the terrain of how the ground features have been uh, established in this city area. So doing this through a conventional traditional surveying work is quite time consuming and has many practical issues. So what you can do is you can rely on technology, scanning technologies like drone based LiDAR scanning or mobile based LiDAR scanning, or you can rely on drone images as well. But when it comes to drone imagery, there are obvious things that you can't cover properly from an aerial image. There are things like that. So by just by integrating both handheld LiDAR scanning and aerial LiDAR scanning, you can cover the 3D point cloud data from for that area, whether it is like a highly active, highly busy city area, whether it is like a forestry area with a large, vegetation density that you can't see the ground level from above, whether it is like within a building or something like that. So you can do this scanning and you can get point cloud data, 3D point cloud data. By using that, you can extract 2D data. So one of the things we can do using point clouds is extracting this 2D data as well. So suppose if you want to create a base map um, for millimeter accuracy, you can derive these things through point cloud. It's not like you are whenever you get the point cloud, you're using it is only for 3D domains, only to build 3D model, only to do that. But to do that, we can of course do use the point cloud for that, but plus we can derive 2D geospatial data using LiDAR technologies as well. And it can be comes in various industries like topographic survey for one example. So whatever the industry that requires doing a survey, ground surveying work, whether it is within the required margins of error, we can introduce LiDAR technology. And of course, when it comes to scanning forestry areas, high densified forestry areas, LiDAR can be, extremely helpful because suppose when it comes to one of the main things in Sri Lankan agriculture domain is, uh, you know, having not counted the agricultural assets, forestry assets in a required area. There are plantations, there are private sector things that has been, they are not aware of what their vegetation extent, vegetation count, and things like that. Whether it is tree, whether it is bushes, they are not aware the exact count of agricultural assets that they have. So when it comes to that, we can use, of course, drone imageries to do that. We can count using GeoAI technologies, but it's true. But when it comes to things like bushes, you can't actually rely on 2D geospatial data and human eye and just algorithm to uh, separate one bush from the another because they are not actually, when it comes to a forest or irregularly cultivated area, you can't actually separate one feature from the other without, without you being on the ground. So that's the case in such situations, and you'll be shown this directly later. We have to do proper segmentation using 3D geospatial data. So in such cases, uh, LiDAR technology is quite helpful, and the LiDAR 360 forestry model is one of the most sophisticated models that been created for this purpose only. And when on the same side, when it comes to uh, doing power line corridor work in electrical sphere, like power line is one of the most advanced softwares have been developed addressing solely to that. So it's quite unfortunate that our initial plan was to cover the whole three softwares, LiDAR power line, LiDAR power line, LiDAR 360 MLS, and LiDAR 360 through our workshop. We actually got the keys and everything for you, but with this given the situation, we have to stick with an online program. Also, what the thing is, we have the keys, but it's not. It requires a high machine power to operate these three softwares at once. So I think it was like a deal breaker for us not to have this in the lab session. So that's why. So, but we can share the keys with you and everything if you are compatible with your machineries with our software requirements. We can share it with you. And of course, urban modeling and geological mapping, as I said, uh, can be covered using 3D geospatial data. So whenever this kind of building extraction and roof classification or city planning, the 3D having 3D geospatial data is a must. Suppose when it comes to planning a city, like in a proper way, you might have to consider about how the sun is being uh, sunlight has been like radiance, his occurrences, everything due to buildings, due to tree assets, and everything needs to be concerned when you are planning a city. So in such cases, you have to do these, slope and aspect and irradiance parameters accurately. And you can do it to some extent using 2D geospatial data, but with having 3D city models, you can do it with maximum accuracy that you can achieve. So these are like that. And also when it comes to mining and stockpiles, and these are things that you have to uh, get the quantify the volume calculations of whether you get a stockpile or something like that for value estimations, things like that. So this requires actually accurate 3D model. So when things like that are required, so you can rely on LiDAR technology as well. So here's the small video. This is actually from a LiDAR green money company, which is being powering this workshop as well as our industrial partner. I think I'm not sure whether you can hear this audio or not because sometimes it can be muted and some videos are actually not audio supported. But I'll show you some of the applications that can LiDAR being used in using our post processing technologies as well. And actually, these are from a few years back. These are actually from few years back. So the current situation is much much more advanced, and we have moved with latest software solutions rather than this. So I'll play the video. These are like actually multi-platform supported geospatial data collection, and we can segment LiDAR sensors to machineries and derive 3D point cloud data, supporting thermal inspections as well. So that's what we are seeing when it comes to agriculture. You can see such application. Of course, airborne LiDAR and UAV mounted LiDAR. That's the technology that we've been using frequently in Sri Lanka. This is actually the software name Crop 3D, but it's been like now a LiDAR 360 have implemented this integrated this solution into their forestry models. So this is quite like in 2017 or something like that. So now it's been integrated as a part of LiDAR 360's forestry model. you might be able to see these things using our data set in our practical workshop. Yeah, there's that. So this is how LiDAR being used in various industries with various platforms and multi-augmented sense as a platform. And this is how, uh, and 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 carried LiDAR sensors and UAV carried LiDAR sensors has been used in various applications. And if you check our social media and things like that, we have uploaded similar softwares and similar applications as well happened in Sri Lanka. So one of the most key components what we use LiDAR 360 forestry module is to segment tree data. Actually, as you can see, this is derived from a high densified forestry area. So you can take your individual tree level for this level. So you can take their crown diameters, kind of, tree girth and everything and parameters related to skeleton of the tree, trunk of the tree, its canopy and everything can be, its crown and everything can be derived using point cloud. So if you are into like so whenever whatever you deal with 3D domain, we can be done here. So now we have moved into like domains like virtual reality. So creating virtual environments for the archaeological uh, locations, heritage locations. This can be done using LiDAR technology as well. So we have done similar projects as like that. So I'll show it to you in the end. So what we do is we reconstruct what it we could have been a few thousand years ago after scanning an archaeological site. So that's how it's been done. So this is what the concept being used might be seen in gaming uh, as well. So suppose companies like Ubisoft or Rocksteady, they are doing the same. They are doing this kind of scans and get real world models, and based on that, they reconstruct a accurate geospatial, accurate 3D model. So that's what we are using to create models, this kind of models in gaming as well. So the local gaming companies like Alimex for their games like Kanchai, Nero, they're using the same technologies as well. So for I think with as per their domain, so this is how it's been done. So whatever you see is 3D geospatial data as can 3D model, it can be derived much more accurately using LiDAR technology. So these are LiDAR sensor types and platforms. And of course, when it comes to UAV LiDAR and airborne LiDAR, sometimes we call it UAV LiDAR, airborne LiDAR as well, because of course, it's area vehicle when it comes to drones as well. But sometimes we separate these two. Airborne LiDAR, sometimes we add the solely to fixing and airplane carried mounted or helicopter mounted LiDAR sensors. When we are using that, we use it airborne. When we use the drones, call it UAV LiDAR, but sometimes we put drone mounted LiDAR sensors under airborne LiDAR as well. So it can be both. And also in LiDAR 360 software, there are two models, ALS and TLS for segmentations and everything like that. And the ALS model is what we use to derive geospatial processing data using UAV LiDAR as well. So it's not that properly defined term. So I have here put in a airborne LiDAR and UAV LiDAR, but it can be used for introduce the same thing actually. Then there's terrestrial LiDAR scanning platform, and if you have seen TLS instruments in your universities or in any other industrial experience, you might have seen, this is what the most standard method of having accurate ground-oriented geospatial data for suppose in the in the gaming experience that I told you earlier. So to derive such accurate ground level experience using geospatial data, it requires technologies like terrestrial laser scanning. Using that to you deriving that to using ALS is also possible, but when it comes to ALS and TLS, TLS is the most accurate method. And it can be highly densified, use point cloud on ground basis. So your point cloud might be not omitting any other ground closing data, unlike ALS method. Then, of course, there are mobile LiDAR scanning technologies. LiDAR360 MLS is basically oriented on using this kind of LiDAR geospecific tools for MLS segmented data. And LiDAR360 can be dealt with both ALS and TLS data. So you'll be knowing this with our demonstration. So here's another small video of showcasing these kind of platforms, but I think it's quite clear for you already. So this is like backpack held LiDAR scanning, and this is like helicopter augmented one, and how it's been deriving 3D geospatial data by going over the surface. This is like another fly backpack one. And actually, there are solutions like grip, and we can carry this kind of scanners in, by hand instead of using a backpack, or we can carry it using, a vehicle. And while going through vehicle, we can cover the city area or whatever the area that we are in. So this is like the backpack oriented one. Again, when we segment, futuristic data use in the ground level, we can use this kind of mobile laser scanning method using appropriate, using more suitable platform. So here when it comes to LiDAR data structures and formats, these are the things that you'll be seeing if whenever you're using this kind of 3D LiDAR data processing software. Pretty much every LiDAR data processing software is using one way or another supporting this data format and addressing these kind of point cloud attributes. And you might have going through, terms like, of course, 3D geospatial coordinates. You have to do it with Cartesian coordinates of X, Y, and you have to deal with three-dimensional C coordinate. And also you have to have an idea about the point density, and how the return signal strength can be. And this intensity tells us how strongly that the laser signal bounce back onto the surface, and based on this, we can have the idea of how our 3D model can to, uh, be derived to this level. And when it comes to return number, it tells us, you know, uh, whether the point that we uh, need to acquire data how came from the first or second or last pulse return. So this is written for which pulse, and this is quite interesting when it comes to engineering sophisticated modeling, and uh, this kind of data is very much critical there. And when it comes to cla- classification labels, and everything that from using geospatial data is about classification, whether you create a land use map or whether you create a vegetation map or any other thing. It's about classifying ground feature data, so it can be used here as well, but deriving them through 3D geospatial data. And also when it comes to mounting these LiDAR scanners to this, and we need to know our scan angles and things like that, because it tells us how far can we off from the vertical when it comes to hitting these lasers on the surface. So these are some of the terms that we using. in LiDAR point cloud processing. And when it comes to supported formats, here you can see formats like LAST and LAZ and E57. These are like 3D imaging system oriented data. And when it comes to E57, it's like TLS, common standard 3D geospatial format. And when it comes to LAZ, it's like compressed LAST file, and LA is like the standard format for LiDAR data. So when it comes to deriving the raw file, it comes in this format. And also uh, there are live data format, and it's exclusive for LiDAR360 software. So if you are using Green Valley produced scanners for your data collection, you can get live data format directly using those scanners, so you don't have to do conversions there. So otherwise, you have to do a conversion to live data format. So this is about like when it comes to core modules of this kind of software. It's basically about managing G3D geospatial data. It's about when it comes to data management, it can be like importing 3D geospatial data, it can be exporting, it can be merging, it could be tiling, or it can be any other organization based on your requirement, or whether it can be like point cloud files. Organizing before the process begins, things like that. And when it comes to strip alignment, it's like correcting positional errors between overlapping file strips, things like that. And after that, again, we have to like classify the point cloud, whether it is whether it is ground level, whether it is vegetation, whether it is something like that. So things are things are going uh, like that. And also when it comes to LiDAR 360, and today we might not be talking about live power line software, but we be focusing on forestry module of ALS and LiDAR 360. It can be divided into two models, actually ALS forestry module and TLS forestry module. And when it comes to drone data, which we'll be using today, we'll be using ALS forestry module. The thing is, both models are quite exact the same, but it's not like we can't use TLS forestry module for drone derived data, but there are some restrictions, but it can be done. But for today's application, having deriving this point cloud data and doing this segmentation using or drone mounted LiDAR scanners is quite feasible. But when it comes to large, densified, highly crowded forestry area, it might not be that handy. So that's why we use TLS in such situations. And if you are using the highly densified TLS derived like the scanning model, you can move with TLS forestry models. So these kind of forestry models are like one click away options and very sophisticated geospecific things. And you can see once the demonstration started, all you have to do is just tick and click, and it comes very straightforward. But there's a huge backend process has been done from the mathematical part, from the development aspect, and also from accuracy verification part, and also things like that. So here are the combination of some nice geospatial concept. So here's actually the software that we demonstrating today, like LiDAR 360 V9. Then you can see to what extent this software can be used. I think audio will be support, but if not, I'll try to explain. This is actually the latest version of the software. I think this is quite heavy for your personal laptops and stuff. So we wouldn't be recommending using this for your personal computers because it can be used, it might can be used, but the processing time can be extensively high, like for half a day or full day processing can be done for even the slightest margins of data sets in point cloud. So of course, everything is now comes with an AI model. So for health center, this has pretty much AI oriented then. And if you have used softwares like X3 and you have seen this partial model section, and this also has this partial modeling section, and also, if you are into using this software in your personal computers, we suggest moving to a lesser version like version 7 or downward from that, version 6 or 5. I think fifth and sixth versions are out of service now, but I think you can manage with version 7. I think we have shared some keys with you for version 7 if you can get them from your organizers. And use them in your personal computers, but we can't guarantee the sophisticated data processing with your, it depends on your processing power of your personal computer. It is how about, doing deep learning technologies and geo AI techniques to, fill the 3D geospatial point cloud gaps of the point cloud that we derive. So it's been done using LiDAR 360 ninth version. And when it comes to tree segmentation, you can have a report like this, which includes every minute detail of individual tree like that. And when it comes to terrain surface modeling, of course, if you can do that to a tree level, of course, you can do that to a ground surface level. And it's like the default uh, compatibilities of this software. Only limitation when it comes to software like this is the processing power because to do it is in a less time consuming, but time efficient ways is to have a machine built for this with required processing requirement. So that's the only reason. Otherwise, it might take quite heavy time to process this data. But this processing workflow is not that difficult, or it's pretty straightforward. Even a beginner can do once you know the detail. Once you know the tools, it's not that difficult. But the thing is, learn knowing the tools is not the case. You have to know what's happening behind these things as well. For suppose if you are doing a geospatial with the doing apply this kind of concept to an unknown area as a data processor. Suppose you are working in this project only as a data processor. So you have to act as a data processor who is not that much aware of the real world ground conditions in that area. So that's why we need to have an actual idea about these kind of parameters, these kind of workflows. Once you have that idea, you can actually read the, residual reports, RMSC reports, and every, error reports that can be derived from this kind of after this kind of process. So to understand that, you have to have the 3D geospatial domain knowledge and geostatistical knowledge that you need to be have there, and somewhat mathematical knowledge. So this everything is required to process these kind of data in a prominent way. But when it comes to using software, it's not that difficult. It's a pretty straightforward process, and it can be done. But you need to know once if something, what if something goes wrong? you need to know how to address it. To do that, you need to have this concept in your mind. So that's why we start with LiDAR concepts first, and then moved into our demonstration. So here are the softwares powered by Green Valley. So today we are focusing on LiDAR360, and LiDAR power line is mainly focused on, of course, power line. The name says it, and for urban areas, city modeling, and whenever you're doing a mobile scanning work, in like in a urban area, or surveying a road corridor or something, like doing a ground asset digitization in uncovered area that can't be taken from area mounted scanner. You can use LiDAR 360 MLA. And here how it goes. And today we'll be focusing on LiDAR 360. And of course, processing workflows is quite straightforward. We import data and do the pre-processing task. When it comes to pre-processing, it's about removing outliers and doing filtering noise and doing subsampling and finally the tiling. So after that, whether it needs to be classified, we do the classification part. And after that, we can move to our outputs, like whether it is a elevation model, whether it is a surface model, whether it is a CHM model, it's canopy height model. So canopy height model comes in very handy when it comes to segmenting geospatial vegetation data using 3D geospatial data. So when suppose you have a area, forestry area that somewhat forestry area has commercial value trees, commercial value bushes, and commercial value any other uh, types of trees. So you need to kind of segment these trees. So you can derive CHM and do the apply parameters to derive this CHM. So based on the parameters that for the tree height, you can derive CHM for each crop. So things like that can be done quite handily using our this software. So, and of course, when it comes to slope and aspect layers, it comes quite, uh, it makes more sense using deriving them using high densify point cloud rather than just using a drone imagery, just using a raster imagery as base. That's all I'm going to say. So finally, we come to the export part, and whichever the format that you prefer, it can be done. So after that, again, these are some of the terrain products that we're going to derive. But today's exercise may be focusing on not, of course, this will be covered, but it's about generating a segmentation report. And I think in our practical demonstration, we'll cover that. And when it comes to ALS and TLS forestry modules, it comes with, you know, the behind the scene is like this this comes with forest metrics, and when it comes to deriving forest metric, the uh, ALS data would not be able to get the actual parametric values as it is as the TLS method. So thing is, when it comes to doing ALS area surveying using LiDAR scanning, there can be restrictions like the proper point density is not matching as to a TLS. So when it comes to doing a large forestry area scanning, use aerial LiDAR airborne techniques. You need to double verify, cross verify these kind of things, because we can generate reports, we can get the data as it is present by the software, but there can be confusions when it comes to actual data. So of course you have to know the somewhat knowledge when it comes to ground data, and somewhat common sense once we do this kind of 3D geospatial processing using ALS, whether it is TLS. So that's it. So if you are looking for parameters like diameter at breast, or uh, diameter at breast height, or things, or uh, crown diameter of the crown, or things like that, mostly preferred technique is to use the TLS module. And whether it is TLS or ALS, of course, we can get attributes to individual tree level, whether it is height, whether it is crown volume, whether it is like its which species it from. Everything can be accurately classified using LiDAR360 forestry module. And uh, also Also, when it comes to calculating indexes of biomasses, that can be done using this software as well. So that's how it is being done. And when it comes to things like volume measurements and cut and fill analysis and volumetric analysis of stock piles and things like that can be done. Whatever that whatever related to volume of 3D geospatial data and whatever that dimensional data that you need to acquire from a 3D point cloud, that can be done. It's like a default thing when it comes to point cloud processing software, not only exclusive for LiDAR 360, but also when it comes to specific industrial applications like power line clearance in the power line sector. Light power line software is there to do this kind of encroachment and sag analysis. And also when it comes to temporal changes over the time using 3D geospatial data, these kind of scanning technologies and point cloud processing technologies quite come in a very time and cost effective way. So from these will be the learning outcomes that we'll be focusing on today, how to, understand the principles and which sensor types, which data format, and fundamental regarding LiDAR technology is being covered by now with this session. And then we move to our software-oriented things. Here you can see the processing workflows and see which product, which outputs that we need to derive when we, exporting data after the processing, and how it is exporting needs to be done in a professional environment, and how proficient you can be when it comes to using this kind of software. After that, you can move to uh, forestry modules and do this kind of segmentation works like that. And if it is, we have time, we can come to volumetric data as well. But it's not that, it doesn't have the wow factor as the segmentation part, I suppose. So let's see how it's being done. And now I will end the presentation. I end my part by showcasing some of the industrial application we done in our uh, by our company in several industry. With that, we'll start end our session. And if you have any questions, I think uh, I'm open to answer once the session being conducted, or you can reach out to us. I think our contact details been shared with you, or if not, I'll share in the chat. So if you have any interest in doing to have this kind of software for your applications or for your research purposes, we are welcome to. We are we more than welcome to you are more than welcome to try and have our technical support as well. And we have these separate coursework modules for PhD students and master students to help them 3D geospatial data for their research purposes. It doesn't have to be them to have a geospatial background, but when it comes to 3D geospatial data, we always try to if they require this kind of domain knowledge, we can cover through short courses, and you might have seen this kind of initiatives being done for some of the international PhD students as well. So you can try as local students for this kind of thing. And okay, that's it from my end. After this, with this video, you can see how we have done this kind of things in Sri Lanka in various segments. So this is how it's being used in building information modeling and how models being derived using and geospatial data. Actually, some of these scans are not LiDAR scanning, some are, like SLAM scanning using SLAM technology. So whenever you deal with, ground assets in 3D geospatial domain or 2D geospatial domain, you can use this kind of mobile scanning parts. This is actually a project we did for Banana International Airport. It's like a tracking spectrum model. Here, this is not actually a LiDAR scan project. Actually, that's in another uh, segment, deriving the 3D model for airport premises. Here, the architecture model using drone survey. So here are some of the asset management applications we engage with, LiDAR 3D point cloud. And here are some of the city applications, LMS derived using 3D geospatial data, things like that. Yeah. Okay. Okay then. So that's it from my end. So the next part of this program will be focused on live demonstration of the software. And if you have the opportunity to have those keys that we shared, you can try this as a live demonstration. If not, I think this session will be recorded and published in YouTube. So you can go through this video again from what we be conducting from now on and do revisions. I think version 7 would be much compatible with personal computers, but there can be lagging, there can be some restrictions, some extensions when it comes to processing time. So that can be expected. So it's not like it's not guaranteed much sophisticated when it comes to processing. Even in our machineries with all this RAM and processing requirements being met, sometimes it take quite time to do some processing when it comes to heavy point cloud data. So that's it from the fundamentals and the concepts of LiDAR 3D geospatial data. So I'll be handing this session over to Eranga. Uh, I don't know whether how the agenda is here. Are we supposed to have a break or something, Dr. Sureka, or how it's going to be? Can we move to directly to the next session? Okay, let's move directly to the next session then. If you have any questions regarding this uh, workshop, you can contact us. So I'll be handing over to Eranga. Thank you very much for the opportunity. See you.
Yeah, thank you, Thilosha. Uh, f- uh, First of all, I will share my screen. I think you can see my screen. Okay. I'm Shalitha from SULECO Private Limited, work as the Assistant Manager of the Survey and GIS. And I'm graduated from the Sabro University of Sri Lanka. So, first of all, we're going to talk about the what are the planning on the other session today. So first of all, I introducing the LiDAR 3C, LiDAR 3 MLS and live power line. Then we go to the LiDAR 3 software and point cloud visualizations and some basic level of identification of the interfaces of the softwares. And then we go on to the point cloud classification. We have several classification methods. We can use machine learning or the deep learning. So we go to talk about the classifications using the those modules. Then we go for the terrain models in here and fish extraction and digitizing and export those digitize feature layers to the GIS background or the CAD environments or any other formats. And then we go to about the forestry modules here. Then this is we have three softwares from the Green Valley International Company. So first one is the LiDAR 360 and the second one is LiDAR 360 MLS and third one is the light power line software. So basically, we use this LiDAR 360 for the general surveying and terrain modeling applications, also forestry and mining application. There are a few other applications in here. So basically, we doing this one and this MLS one is for the street data asset extraction. I mean, so in road corridor features, road furnitures, and other road features can be extract from here. And also we can process the um, live grip data from here. I will explain what are the instruments used in here and how to process those data. So another one is like power line software. This is mainly going on the analyze the power line and inspection. We can predict the vegetations and some of safety vegetation management in here. And sag analysis also we can do. Also wind analysis we can do with this one. Okay. Then I will move to our softwares. Um, this is the LiDAR 360. For the LiDAR 360, we have this interface like this. In here, we can see layer panels. And in here, we can add the point cloud, and we can add raster data, vector data also, and we can add CSV like table data, and models, trajectories, and other things. So first of all, we can add the point cloud here. In click in right click it in here and import. Then you can go to your directory and you can add the point cloud here. The thing is that in Power, these softwares, yeah, this is one. Why we use to this LiDAR 360 and other softwares, because of these applications remove major limitations of the point cloud management. Well, the when we are managed and handle the point cloud using the several other softwares, it's a limit to our uh, performance of the RAM. Capacity of the RAM. It's mainly depend on the RAM. So this point cloud load into the RAM, and it's a case to the freeze and instruct our machines. So the slider 360 can be used we can use for the large point cloud data, and it's not directly load all the point cloud into the RAM, and they have another structure for this, and we can work with a large data set like 300 GB data sets. It's based on the your machines, uh, PCs specifications, but other than the most of the softwares, we can recommend this one is for the your point cloud handling software. Then we can go to the this LiDAR 360 MLS one. So we have V9 versions, and here we can do several applications here, like these floor plans and if gate service, uh, survey and beam analysis also here, and can go with this one. Yeah, and we have these applications, and I see that previously Ms. Thilosha introduced this instrument in here. So we have this type of airborne laser scanning, handheld laser scanning instrument, and mobile laser scanning, also backpack and GNSS. So we have these processing softwares for this one, and now we can go for this one. In this software, we can access to the automatic AI classification of the point cloud. So we can classify the point cloud using the machine learning and deep learning. So this is the raw point cloud we can see here, and this is the classified point cloud. So here, all the static cars and buildings and vegetations, ground points, or all the points classified into the several classes. Uh, then we have AI assistants also. Uh, we can use this software for the classification like this, and all the buildings, vegetations, and water area. Also, this is another rural area, and also we have the forestry modules here, and power line softwares. We can scan tunnel and classify them in this one. Okay. This is about the LiDAR 360, and we have of the LiDAR 360 MLS one here. And this MLS one, we can extract the building footprints and this one beams. And this one is another application of the LiDAR360 MLS. We can analyze the trench and automatically detect all the things. I will explain how to do this in here. And now this is the live power line software. We can classify all the raw point cloud into the classified point cloud. This is mainly doing with machine learning and deep learning module. Mm, Also, we can identify all the power lines automatically. Um, okay, we will move to the presentation, and I think you can get some understanding of the point cloud. I also mentioned that in here. Point cloud mean it's contained larger points of the real world objects with the XYZ coordinates and RGB values of the point and intensity values and several attributes on there. So the collection of these those all the point we call the point cloud. So then um, we can go about the point cloud classification. In here, point cloud classification, we can classify all the raw point cloud like this one, like this point cloud. We can classify for the vegetations and roads, buildings, and other components are road corridors, and we can also get the light poles and all the. Here is the some common uh, classification classes in here, and those numbers in here, the zero. Also, always we use zero for the created or never classified point cloud, and also after we classified, if remaining points that not going into the any other classes is called the unclassified point cloud. It's going one. And all the ground points of the point cloud, we go to in the second as the number two, and low vegetation like this. You can, okay. Then we can go with this application here. Here we have the point cloud like this. Here very small point cloud because of the time consuming workflow. Uh, Here we can visualize this point cloud like this. The one of the thing is that mainly we use last point cloud. Dot last point cloud is the for extensions of the point cloud in dot last. But when we import the dot last format into the our LiDAR360, it automatically convert into the live data formats. We can import those point cloud like in last format, ASCII formats, and PLY E57 or the PCD point cloud. And mm, in first case, we import these any of other formats like last ASCII or other formats in here. It's create get some time for the converting those point cloud into a live data file. Then we can import those live data file, and it's not take much time like this. It's very it's a few seconds we can get any of large point cloud here. So we're going to add some data set here. We can add this one. Yeah. So it's in live data formats, and it's going to the this one, and like this. We can add all the data. Other ways, we can drag and drop all the live data files in here for the uh, like this. we can drag and drop into here, and it's automatically added into our workflow. Okay, then we go with this point cloud in our LiDAR360 workshop, and here we can visualize those point cloud with several factors. This one is the RGB one, and here we use RGB one. It's visualized by the actual RGB values in our data set with all the RGB true colors can be shown in here. And then we can we can visualize this point cloud by height density. So it's like this, it's automatically added the color ramp for all the point cloud with their comparing their height, and it's mainly going in here. Yeah, like this one. Uh, it's automatically added the color ramp by comparing the lower value of the point cloud height and the high value of the point cloud. And like this, we can get some information before the processing our last deliverables in here. We can get idea from this, and also intensity values. We can visualize by intensity values here, and we can if we have the classified point cloud, we can visualize by the classification uh, based on their classification. But here we have not all the classifications added here. So going through our workshop, we can classify all the point cloud. Um, then also we have the return numbers. Thus, return means when we capture the LiDAR point cloud by our uh, sensors, it's depend on the sensors, but this point cloud captured by Zenmu's L2 sensor, LiDAR sensor. So it's create the five returns. Those five returns mean the when we emit the layers of pulse from the uh, our sensors, a first reflect of the laser pulse, it's called as the first return, and last reflect from of the laser pulse get as the fifth return. So it's very important for us because of if we want to get the points of the very canopy area, we can get the fifth and fourth returns from the ground. So it's very useful when we are creating the terrain models from very canopy area also. Okay, then this is the point cloud visualization one, and other thing is all these interfaces in here. We can have access to several glasses and contours. We can um, basically we can generate the contours of the point cloud. After we processing all the data, we can get out the GIS layers and other things. Also, we have ideal high dome light display options in here. Uh, Also, here we can have access the uh, view navigation for the and it's like top view and left view like this. Then we have the orthogonal projection and perspective projections also here. So we can go to the 3D and 2D domain. We can in here we can move only out from 2D, and here we can move on the 3D part. Then we can get the cross sections also here like this. We can get cross sections and edit our buffer zones here. Okay, so these are the several uh, visualization options in LiDAR360. So we have another facility for the toolbox. We have several toolbox. It's like history uh, moment, and we can get search. We can search any tools in here. Also, we can pick the point coordinates from here. Those are all the values of this point. We can get all the coordinates, XYZ coordinates, and intensity, return number, which return is belongs to this point, and classification. Also the RGB values in here. So if you want to pick the any points on here, we can create like this. We can pick any points here. Okay. Also we have the measurements for the length measurements or area measurements. Also we can get height measurements in here like this. We can measure and area also like this. Okay. This is the very basic one, and here we have the volume measurements. If we have stockpiles and any of the places we want to get the volume of the those area, we can get using this one. And here is the selections, and we can get select the point cloud, and we can cut the point cloud by this one like this, and we can save all the things in here. Also, we have several extractions. We can um, we can extract the point cloud by several classes or elevations. If we want to uh, get all the points in these elevations or above those elevations, we can use this one. And yeah, also we can convert point cloud into the any other formats. And here we have all the raster conversion tools for the converting rasters, like of the if we have create the DEM, we have live model, and we can visualize the all the DEM in a 3D domain. Yeah. And yeah, those are about the tools in basically we use in LiDAR360, and we have point cloud registration also. I think if we have our one point cloud with a georeference, I mean of the actual coordinate of on the ground. But if you have another point cloud with any uh, non-georeference point cloud, we can georeference or we can merge those point cloud with registration. And we have vector editor for here. I will explain this one in after. And ALS and forestry modules in here. Also, we want to go to the LiDAR360 MLS one, and this is captured from the SLAM dataset, SLAM instruments, and it's mainly all the visualizations and tools are mainly same, but this is the SLAM dataset collected in Sri Lanka, so we can visualize. We can now see all the ground points and uh, trace. Mm, well captured in here, and we can extract all the we can see all the roads and road corridors in here. So this is we how we can see how to extract all the features in here, and this is these tools for the extract all the features in here. And then we have the live power line software. This is the live power line software, and we can analyze all the uh, point cloud, all the vegetations, and we can identify what are the danger vegetation area, and sag errors, and we have also the wind analysis in here. We can run simulations of the power line in here. Yeah, this thing. Okay. Then here is the terrain module, and we can go with all these terrain modules, and we can create the DEM, DTM, and DSM, also other contours and other things in here. By this is the one of the uh, projects we have done in our company, and we have 2D image coming from the drone data set and the DTM and DSM, also the contours. Here is another digital elevation model, and this is a visualization of the live model. I will explain what are the things. Okay. Um, Here first we can use this data set, and we will create the DEM and DSM, also the uh, other terrain modules and contours from this data set. So first one is this data classify as the ground and never classified point. So if we have any unclassified point cloud, mainly we get a raw point cloud. It's not the classified, and we can run the classifications in here. So we can classify the point cloud by the we can classify the point cloud for several classes also, and we can also classify only the ground points. In terrain modules, we can classify the all the ground points using this one. Before those classification, it's necessary to remove the outliers of the point cloud, raw point cloud. It's we can remove the outline. It's just click, and you can adjust several parameters in here. But here is the neighbor points distance, and this one. It's okay for the default one. Otherwise, we can change the parameters in here. And here we can classify point cloud by classification, classify ground points. And this one is we have several parameters. We can classify by the all the point cloud or raw point cloud from this raw point cloud to ground points, and then we can select what are the scenes here. It's mean what are the undulations, like it's is it a flat terrain or a gentle slope in here. Also, for the steep terrain, we can use this one in very hilly area. Also, step by if we have undulation like step by step, we can use this one. In here, we use a gentle slope, and you can add the uh, max building size. It's mainly going on with the diagonal of the building size, and you can add several parameters in here, and you can click OK. It's automatically identify all the points in our data sets what are the points belongs to the ground, and they classify the all the point cloud in here. This is the workflow for the create the for the DEM and DSM using the point cloud for point cloud. Firstly, you have to remove the outliers, and then uh, you want to classify the ground points. Uh, and when we are classify the ground points, is classified like this one, and we can off the unclassified points, and this is the ground points in those areas. So with this one you can identify this is the building area here. You can identify this building removed from the ground points, and all the buildings and vegetations removed from the point cloud, and all it's classified the ground points only in here. Then you can go with this based on this point cloud. Um, you can create them DSM and contours and other things. In here, we want to sure that we classified all the point cloud are correctly to the ground. Otherwise, it can be classified in other buildings, rooftop, and other thing in misclassified. So we have the classification editor for that, and we can manually classify those points. If we think these points are in misclassified, you can select those points, and you can from class you want to select the what is the class of the those point cloud, and what are the two classes in here. Um, in here, I will select the ground points, and we can classify this as the buildings if we want if we want this one, and if we want this one, we can classify as the in here. Sorry, like this. We can select, and it's automatically classified. Then we can save those results in here. Okay, I'll not save the result, and then we can classify the DEM. Sorry, we can create the DEM from this data set. And here we have general and standard for the scale, and we will go with the general one. And here we want to define the what are the resolution size. I mean of the GSD ground distance resolution. So we also called resolution of the spatial resolution of the DEM. So it mean 1 pixel, how much of distance on the ground uh, interpreted by the 1 pixel size. So we can define that as the as our needs. So we can define in basically we do it zero point 0.5. If we want 0.25, we can use in here. Um, and we can also adjust the buffer size if we have low density and that. Also, we have three method for the interpolations in here. We have IDW and Priggin and Tin interpolations. Uh, Here, the IDW means inverse distance weighted method, and Priggin also the another method used in DEM generation. So we can use IDW. It's mainly going on the ground, but Priggin also provides some smooth DEM. We can't define this one is the best for the our module. It's depend on the your applications and next application of the this. Also, we can take the fill holes in here also, and then we can run this one. You can also set the output path in here. We will see how to generate those temp files in here. You can add this model here. It's generate the high resolution DEM in or the zero point 0.5 resolution, and now you can convert this into the LiDAR live model. It's natively supports in LiDAR 360. So we can create this TIFF file for to the live models, and you can like this, like this one. So if you want to view the 3D in this dim, you have to remove those of the raster layer from here. Yeah. Then you can turn it into the 3D domain and like this. It's generate the dim, accurate dim for the our terrain. It's you can identify if you have any uh, mis uh, misalignment in here, and you can edit those in a point cloud. Here is the high resolution then, and then you can go with create the contours for this one like this. In here we can create contours using this tool, and here you can define the spacing, I mean, or the contour interval of the our need according to our need. So here I define it as the zero point 0.5 meter, and also you can select the colors, and you can define the major interval distance in here. Also, that's a very important one. We want to select only the ground points for the our contour workflows. We can create the contours using the other point clouds, also other classes for according to our need. And if we want to show the terrain, we only select this ground, and yeah. Then you can define your accuracy level, and it's automatically adjusts all the point cloud and other parameters according to our accuracy level. And you can also get a terrain smooth, and you can smooth the contours in here, and click OK for the generation. It's here you can see how the all the contours this all the contours you can export all those contours as the DFX. So yeah, and here you can generate the shape files, DFX or GeoPackage in here. If you want to use a DFX, you can generate GFX. Otherwise, if you go with the is GIS domain, you can use shape files here. Then you can create DSM also in here. This it's a different. It use all the classes in our point cloud, because of DSM mean of the is a surface model, and it's generate the whole surface. Here we have also three methods for the DSM generation, and you can click OK. can adjust all the parameters if according to your requirements in here. Yeah, I will remove these vector layers from here. And this is the DSM straight from our point cloud, and also you can convert this into the live model if you want. Um, Most of this one is with our outliers, so it's that's why we need to remove the outliers. And yeah, also we can generate the tin model in here, and we can add the civil 3D or other softwares. That's this one. Okay. Now we can go with the feature extraction in here. So feature extraction in here is the convert. It's not convert. It's not automatically convert all the data into the uh, vector layers, but we have semi-automatic way in here. Also, we can manually digitize using the point cloud. And here we can see we can extract road and road furnitures and road elements like this. We can extract the road elements in here. Also power lines like this. We can extract the power lines uh, using the LiDAR 360, also the LiDAR MLS. We can use both softwares for this one. And building also classify in here. And also infrastructure facilities and utilities we can digitize using this one. Okay, can go with those fish extraction one. So first, before the fish extraction, we need to classify our point cloud. Now, we have several classification method in here, and first one is the classify by machine learnings. So if we have training classes, point cloud for the classification, we can import this one into the here, and we can run for this one, and we can get our supervised classifications in here, and you can uh, classify all the point cloud into the this one. Other one is we have a deep learning one. This one is pre-built-in functions in our LiDAR360 modules, and we have several scenes for here. We have UV urban, UAV urban dataset. If we have a UAV urban dataset, we can classify using this one. Otherwise, if you have rural datasets, we can use this one. Also, we have TLS datasets coming from the terrestrial laser scanning um, instruments. We can use this one also. In here, also we have the MLS rod. If we have rods, basically on the like this one. If we want to classify all the features in here, we have use this one. Also, TLS forest also. Mm, This is the this is on the LiDAR 360. If we go into the classification on the LiDAR 360 MLS, it's uh, classify other way all the data, and we have any other several outdoor um, scenes and indoor park and the forest garage railways like this. We will show what are the relations in here. So here we can classify this point cloud using this one. And the thing is that firstly you can select the what are the point cloud, what's point cloud want to classify in here, and you can select as the classes in here, and then you can use this one classify and classify vegetation and other things, power lines, towers, and this. And you can click OK to classification. Take a few minutes. Here also have the classification for the deep learning. We will explain that after when we're completing this one. This is classification custom deep learning. So if we can create the custom data set for the deep learning, we can classify using this one. Also, we have classification editor for the classify all the uh, mis misclassified point cloud. Also, if we want to classify the point cloud by manually, we can type this. Here is the classify point cloud, and you can identify all the uh, buildings, vegetations, and power lines also. Yeah, power lines are classified by yeah, and we have several misclassification here. So this is belong to the buses, and you can manually classify this one or use of the other modules in here. You can use other modules in here and select from the building layers. You can select the building layers here, and then you can go with this one. This classify only the building layers into the these one. These other point cloud. If we can't specify the all the point cloud by according to your data set, you can manually classify those there. Also, this is the vector editing, so we want to feature extraction in here. Uh, we need to create the vector file or select vector file, or we can create the temporary vector layer in here, and then we can use these drawing features like a point, top, lines, polylines, and this and polygons also there. We can classify using this one. We can extract the features and digitizing the features using this one. Also, we have several semi-automatic way to extract the features like building footprints and other thing. I will explain after this one. Yeah. Okay. It's classify the static cars or cars also. Yeah. In LiDAR360 also you have some basic applications of the live power lines, and live power line uh, is the another software for the only for the power line and applications, but in LiDAR360 also we have can access those features using the license. When you are selecting the license modules, you want to select what are the uh, features you want in here. Okay, then we can go with the several case extraction one. We can create the first of all we can create RGB image in here, and we can go to the vector editor and create a new temporary scratch layer, or you can if you have some layers in shape files or DFX, you can add those data into the workspace, and you can select those files. Here, I will go with the temporary files, and here you can extract the feature using this one. It's like this. If we want to digitize all those if we think, you can do this with like this and select the point, and we have also the curvature here. Sorry, we have use the curve as arc one, and like this, and then we can go with again line like this. This is going on of the LiDAR360, but if we have the LiDAR360 MLS one, we can extract this one with a semi-automatic way. So I will explain in the Lava LiDAR360 MLS session. In here, also we can these cross road crossings also we can extract by semi-automatic way. It's a very simple one, and also I want to show this one. Here we have several tools and delete and edit reshaping tools here also. Then we can go with the extract building footprint and extract the road curve here. Here we can extract the road curve using this one. Also, I will explain this the buildings one. We can if we have the classified point cloud. Sorry, if we have classified point cloud, we can display by classification. So here we can classify display the all the point cloud with our classification. So here we can extract the building footprints. If we want, we can draw the features using this one, and you can completely draw the polygon here. Otherwise, LiDAR360 provides some semi-automatic way to extract the built-in footprint using this one, and here you have to use this with like this. It's automatically identified. Sorry. Yeah, you want to do create the point cloud like this. Not going in here. like this. You can extract the building footprint using this one, and in there you want to keep only the building layers in here, and like this. If you have a well classified point cloud, it's very easy to also detect all the points in here. So if you can use this one like this, you can extract all the buildings like this. But the important thing is we will need to classify our point cloud uh, very accurately. So if we classification it's correctly if we classify the point cloud with correct way, we can extract all the features like this. Also, you can go in the road curb also here, and power lines also you can digitize using this one. The thing is that you can this all the data in digitized data in 3D domain. So always they the include with the height values. Uh, you can analyze in 3D domain here. Yeah, like this. If you have good power lines, you can uh, have it, and you can just another temporary layer and rename it. And here you can extract the power lines also here. You can extract those power lines using the error MLS. This very this MLS have features to semi-automatic feature extractions, and it's very uh, advanced tools, and you can extract all the point cloud in here. So I will go with this one also. Here, this is the previously I mentioned that this is captured from the SLAM instruments and handheld SLAM instrument, and you can see the high density point cloud in here, and also this in Sri Lankan data sets and data set in Sri Lanka, and in LiDAR 360 MLS also we have the several options for the display by RGB, display by classifications here, and like this you can classify all the point cloud with buildings and vegetations. So in our models, if you want to classify these trees with tree trunk also, you can use these urban forestry modules. I will explain in the forestry module. And here you can see the classification, and here also all the height display by the heights in here. Mm, here is the data set from Sri Lanka. And then okay, we can use classification also here, and we can use classification like this. We can use deep learning classifications, and here we use road MLS and using GPU. Yeah, it's you can set up in GPU or CPU. And here we have the NVIDIA GTX graphic card. So it's a mainly time consuming. So I will classify this data sets. GPU. You can see what are the classification here. Also, this module provides some of the vector editor tools other than the more than the LiDAR360 software, and you can create some uh, the soft other feature tools here. Also, can use map element. It's mainly used for the feature extraction of the road corridors. Uh, here, so here we can use semi-automatic way to extract the road curb and road center lines, road features like the road markings also, and we can add road markings here. We have several options in here, and if we have the Sri Lankan database for the according to our road markings and our shapes, we can upload this one, and we can use road auto matching tools for this one. It's automatically analyzed by the images, and they automatically assign the this is related to the belongs to this road marking. Here, the important thing is if we have the instrument on the Green Valley International, so it's like a handheld SLAM instruments, and we also have the uh, vehicle mounted LiDAR uh, instruments. So, it's automatically captured all images and LiDAR point cloud simultaneously. Then we can use the LiDAR360 MLS, and automatically they they support all the feature extraction using our very uh, automatic way in here. It's mean if we have the billboard, road signs, and uh, those like these poles and road markings also, they captured everything, and you can use these road automation tools for extracting those elements in the tools. Also, okay. Here we have the classified point cloud, and you can adjust the parameters according to your own, and you can use this one for the. I will remove uh, unnecessary classes from here. It's very important also. If we run on the any of the road, it's usually have static cars, dynamic cars, also the pedestrians in our data sets. It creates a high noisy point cloud. So we can remove those all the uh, static cars and other unnecessary noises from our data set using this classification. That's why we need classification. And then here you can see there low vegetations also. Okay, so now you can remove out all the vegetations, and this is point cloud, but Here we have not adjust the parameters, so it's can be case to misclassified point cloud. Mm, okay, you can adjust the parameters when you are working on this, and then we can go to the road extraction here. Here, so if we want to, yes, the first thing is if we want to extract these road markings and road curves in LiDAR360 MLS, we have uh, detect lane lines and detect roadside lines like this. If you have selected these semi-automatic lane detections, you can go with these parameters. Also, you can add the stretch length and line width. Also, you can select the line type, like it's a continuous one or the dash one. In solid one, we can select solid one. Then you can adjust the these point cloud to the very visually appearance one. So here thing is that we want to select this one and pick the point where the away from our slide line and click this one also and click on the uh, our slide sidelines and what we are want to detect. In here we have a semi-automatic way to feature extractions, and here need is you need to give the starting point of the rods, and then you can pick out the second point of the rod. And sorry, do it again. It's automatically identify all the other continuous lane like this. And in here, you can pick this one, and here, and you can pick this one. Sorry, and this one, and if you are hard to identify, you can pick like this. Yeah, you can pick this one. Sorry, I'll pick around there, and you can pick these road sidelines here, and then you can untick this one, and you can use a starting point. There you can do the ending point. Can be it if it's wrong, you can right click to the correct point, and then you can select this one and go this way like this. You have several instructions for the this one in here. You can do like this and this one also. So automatically detect like this. If you have the high density point cloud and all the noises and other removes, we can do this one very professionally. And also they have detect the dash lines. If we want to the digitize those dash lines, you can pick this one, and Here we have several like this, like this, and you can pick a starting point and second point. Also here you have to pick the another third point from starting the dash line, and they automatically detect another points. If we have like this, here also you can pick third points. So automatically detect all the lines in here. So it's very important for the feature extraction in road corridors and road furnitures like this. Okay. You have any other ways also doing this one? We can create the road center line, virtual center line, and uh, we can create this one also. And yeah, another thing is that we can detect the road curb line like this. Using this one, we can detect the road curb lines. So we can doing this one in you can select the what are the type of the road curb or closer to the floor bed and flower bed or close to the isolation street. And you can also select the left or right. What is the side of the this one? And what is the position, line position? It's upper of the this one and the lower of the this one. Here we have used this lower of the curve line. So we use this one and we can click here like this. We can click here. It's automatically detect like this. We want to give some guide to detect. That's why it's called semi-automatic. And like this, it's automatically detect all the lines here. The thing is that we have not captured all the data in here, so that's why it's not identify the all the data. If it's go wrong, you can use the line like this. This is a very dynamic data set, so we have not a float curve line is straightforward for so this area we have to do some manual works for this one. And another thing is we can get those road crossings in here. So for the road crossings, we can use this one, add road crosswalk, and Like this, you can add the road crossings like this. But this is the predetermined pre-built crossings. You can select this one and here to create the road crossings. You also have the road template machine. So this one is very helpful. Mm, we have here is the attribute table. This is the all the vector layers, and we you can use attribute table also. View attribute table also here, and it's automatically add for the all the so automatically add all the vector layers when we are using the tools. Automatically add the relevant vector layers, and then here is the road auto matching techniques, and you can just crosswalk in here, and here you can create the center line of the road crossing, and you can expand it into the and it's automatically detect the road crossings like this. If we have our this is the case of the our objects the in the ground, they have not have all the features like this. And if we have the clear data set, we can do this yes. Then another thing is that if you have this type of no parking zones, we can create like this. You can use these tools, and you want to give this like this. You want to select the firstly you want to select the what is the area, and then you want to select one line, and then it's identify the what is the interval, this distance of the two lines, and then they have created. You can use this and practice with this. Also, here we can add the facilities. These these things are built in from the software. If you want to add more things, you can add and customize our road markings. In here, we can add also the facilities also. Facilities, we can like this. We can add the poles, detect power lines in here. Here we can add the poles and power lines. Also add traffic signs here. Then we can use the parking spots, also manholes and drainage drain. So here we can see some several manholes here. So I will add one manholes, and you can see how to add it. Here you can define the radius of the manhole, so we can use the standard size, and then we can click here. It's automatically added into the manholes. Also, we have this one. You can edit this one, and yeah, if you uh you can define the as a standard size for this one in according to Sri Lankan Sri Lanka. standard in Sri Lanka, and you can click like this. If you want to rotate this one, you can use R and T for rotate like this. Mm, yes. Then any other thing is if you have like these letters in here, you can use add letters in the fonts, and use you can use the font. It's not automatically detected, but we can use this one like this. Yeah, you can use the capital letters like this. Now to delete this one. Okay, like this. Mm, like this way, you can extract the features in road corridors and other things. Also, if you have a poll like this, can use the classifications and can detect pole and what type of pole, traffic light or street light, and then we can select the top of the point. Sorry, here, and it automatically added all the poles here. So yeah, now like this way you can get all the page extractions and this. Also, you have the thing is the road facility detections in here. If we have the template for the our according to our uh, signal lights and road signs, all the things you can add here, and you can train the data sets, and then you can digitize all the features within this one. Yeah. Also, if you have linear detections for the if you have some lines other than that of road center lines, road side lines, and other thing, you can uh, create temporary. You can train temporary model, and then you can extract all the points in here. Okay. Yeah. It's like a segmentation. So you can segment all the things. Yeah. Yeah. Like this, you can do the feature extraction in this one. Also, we have our the like power line software for feature extraction. If you want to extract the features in all those power lines, all the components of the insulations, the wires, and other all the things you can ex extract by using these power line tools in here. It's have another workflow for firstly we have to detect all the towers, and then we can there we have also the semi-automatic way to detect all the power lines, uh, vectorize all the power lines, and other thing is we can do the simulations in here, including the several like wind and other factors. S- s- if you are in the architecture side, you can use the floor plan and gets analysis and beam analysis here. Beam create using beam within this one. Also, you can link the Revit with this software, and you can model this one. Uh, Also, we have others, several other d- domain in the mining and other thing. We can detect the pipelines and its trench detections. Automatically, they can detect the trench in here, and those type of features we can extract from the point cloud. And yeah, another important thing is in here we can uh, do a road analysis and road terrain analysis in here, and we can create the we can analyze the roads clearance and other thing is like this. If we want to analyze the road modules like this, we can analyze the vegetation. It's vegetation that danger to the our roads and road area. So here we can draw a line like this, and it's like this. And then we can adjust the parameters. Adjust the parameter. This we can adjust the parameters like the 5 meter or it's depending on the our vehicle clearance area. Like if we want to clear those areas from ground to 5 meter to up, you can use this one, and then you can click OK. Uh, yeah, here you can use up the high vegetations and low vegetations. And then it automatically run and analyzes the what is the area of danger points here. And it's very important for the urban forestry and forestry management, urban forestry management. Also, they have generated individual reports for the individual trees and the thing, and you can get the locations and you can manage. Also, we can create the road terrains analysis. Also, the road scene, we can create the road scene. It's like we can create the digital twin like of the all the roads, and then we can analyze this other uh, features, and you can manage the infrastructure facilities using this one. Let's take a few minutes for the uh, uh, it will process and we going into the next one also. Yeah. Here's the forestry modules and forestry modules. In forestry module, we have access to, we can access the forestry module using the LiDAR360, also the LiDAR360 MLS. And it's automatically identify all the uh, canopy areas and vegetations as previously. Also, we can identify all the trees individually for our requirement. Oh, we can do this with our own data sets, and also here we have how to create the another model. It's mean a CHM. It's canopy height model. It's derived from the DEM DSM minus DEM, and it's a representation of the actual height of the vegetations. And from this, we can calculate some matrices of the biomass and other all the things in. Yeah. with our it's create like this because of we have defined that as the 5 meter 5 meter clearance. So it's create the 5 meter clearance from all the areas, and like this it's automatically detect what are the areas need to remove or clearance. And think this very useful when we use the urban forestry, maintain the urban forestry, and all the things. Yeah, it's automatically detect all the height and points. You can export those points and export those points, and you can guide to other workers or other uh, members into those area for visually verify your this and get taken actions for this. Um, it's like this. Yeah. Okay. Then we can go with all the forestry modules in here. Here, we have the several modules like ALS and TLS. ALS for the airborne LiDAR scanning, and TLS terrestrial LiDAR scanning data sets. But as mentioned in previous sessions, we can use this one for the other data set. It's mean we can use these features for the ALS data set also, but it's not the optimized for this one, but we can use according to our workflow. And here we have the ALS, and we can we can generate the CHM first. And yeah, yeah, we can we have previously created the DEM and DSM also. We can import those thing. Otherwise, we can create from here. Yeah, previously I may mention that if we have after the digitizing all the layers, we can export those layers like this. For the we can export all the vector layers like this, and I yeah, we can export with coordinate conversions. We can use a coordinate conversion if we have like what is we mainly use the SLE99. You can also use WGS84 also. Yeah, WGS84 or SLE99. And if you need to convert data into the another coordinate system, otherwise it automatically take the coordinate system of the point cloud, and they automatically create. You can it's automatically georeference in your data set. So you can choose what are the export type, shapefiles, KMLs, KMSets, and GeoJSON DFX, also XML. And this is regarding the coordinate system conversion, and it's 7 parameters you can use if uh, your coordinate system is not in the database. You can use the 7 parameters and create another data sets. Yeah. And you can click OK to export all the coordinates, and you can import into the ArcGIS or any other GIS softwares, and also you can use in Civil 3D. Yeah, that's the thing. Okay, then we can go to the forestry modules. And in forestry modules, you can, as I mentioned previously, you can create the DEM and DSM here. Again, the same window, and you can create the DEM. You can add this one in. Here is the previously I export all the data sets, and you can see here all the data sets. I think it's not classified as well. Mm, Can do terrain classification first. Yeah. Yes, then you can create a dam here. Yeah, it's automatically added in here. Then you can create the DSM also. Yes. You can select the color ramp for this, like this one. This is also. Then then you can go with the ALS model, and you can create the uh, CHM model in here. This is the general workflow for the segmentation. So you have remove outliers and other pre-processing steps. Then you can create and classification of the ground points, and then you can create the DEM and DSM, and finally you can create the uh, use the DSM and DEM for the uh, CHM model, and then you can run the normalizations. Normalize means if you have a high undulations terrains, it's normalize all the height of the uh, ground points to the same level. It's mean it's important for the identify the tree heights and other things. So we have to normalize the point cloud by normalized by them or normalized by ground points. Here we can use this one, and we can normalize the data. Yes. Then we have normalized data set also, and here we have normalized data set by ground points and all the data sets. Then we can go to the segmentation. Here we run the segmentation, the point cloud. By here we use only the normalized point cloud, and I go with the default parameters. You can adjust this one, and here note that that's the input point cloud data must have normalized elevation values. So you want to use only the normalized. It's automatically create the vegetations and automatically detect some points of some of it's generate the points. It's called seed points, and automatically create the one seed point for one tree. So it's we can use this one for the tree counting also. Um, yes. It takes several sorry a few minutes because of here now segment all the tree by individually. Also, we have some machine learning models for the this one. You can add the tree table using this one, and it identify like this, like this. They have assigned 1 point for each. I think you can see like this. They have assigned 1 point for all the trees, and here also they have segment all the trees individually. So here you can remove this. I will show in this one in 3D domain after our first matrix calculations. And here you can calculate the first matrix by grids. So basically we want to this for our forestry analysis, like how many vegetation sorry density of the vegetation, and like this one we can use these matrices like elevation matrices, and leaf area index also use, and canopy cover and graph actions. Those data we can get from analysis these calculating the forest matrix. Then you can get this one as a CSV file also, and a TIFF file also. If you have any questions or something, you can give it into the chat. We will answer for this. These metrics also calculated, then we can see the attribute table of this, and it calculates cell size, and it's we can create also TIFF images using this one, and it's automatically create the XY coordinates of the center of the pixels and canopy cover and all the matrix values using this one in here. Also, we can extract the individual tree reports by using this one. Uh, Here, we calculate some several dBH and other values. dBH mean the diameter of the tree trunk from the standard height from the ground. It's go around 1.5 or 1.7. And we can generate the individual tree reports with all the individual trees and uh, their statistics here. Here, this one is the individual tree reports, and here we calculate all the parameters like tree position, tree sets, and tree height. Also, we can calculate and crown diameters according to the directions and crown area and crown volume. Also, here we calculated. This one also used for the biomass calculations. And here you can access some tools in the TLS for us, tree modules, and you can specify the tree if you have the same classes, tree in same classes, so you can get using this one. So you can get attributes like this statistics of the individual tree, and it's same like previous one. Also, you can manually measure the dBH for each trees here. And yes. Also, previously we have normalized all the points, but then now in the finally our works we can denormalize our point cloud. So it's automatically create the actual heights, the point cloud. Yeah, I will show the individual individual tree segmentation in here like this. They have identify all the trees by individually like this one. Yeah, this is end of the forestry modules, and I also go with several. I will introduce some applications of the live power lines also, and here we have access to all the previously options like this one we can visualize by the ground points and classifications. Here we have to the workflow for classification and detect the power line needs based on the which kilowatt voltage level. And yeah, firstly we want to identify the towers. We want to mark the towers in here. Point. Here, firstly we want to mark the towers. Yeah, like this. One, second one, third one. This and then we can run the classifications, and we can classify the shell line insulators and all the things. And also deep learning or conditionals. If we conditional, we can adjust the parameters according to this one. And if we have deep learning one, we can deep learning one. And buildings also can classify. And can I start? So This light power lines also the very important because of it's mainly for the power line analysis and mainly for the power line analysis, and we can as I mean previously mentioned, create the we can analyze the danger points for the vegetations in here. Also, we can analyze the we can analyze and the simulate the wind situations. And according to these situations, what's happened to the power lines and how is the sag errors according to temperature, sag analysis according to the temperature and the wind. We can analyze the swing of the power lines. It's like this. Here we can automatically identify all the wires and insulations also here, insulators also here. Like this, if you have of the high density point cloud, this one is actually this one is not for the uh, these applications. So that's why we not captured the whole the high density value, but we can uh, run the survey for create the high density point cloud using this one, and it's automatically identify all the ground points like this, ground points and all the wires and insulators, towers, all the things in here. And then we can create the 3D profiles also here, like this. It's like this. You can get all the measurements and can create if we have unclassified point cloud, we can use this one to create classified correctly. And then we can also identify all the ground points like this. We can analyze the terrain and all the things in here. It's like the shell wires. We can like this. You can identify all the things, and then here also we have the vectorization part for the create all the points. Yeah, and we can real time simulate the real time conditions with our this one. Also, we can do the tree growth analysis. It's mean firstly we can get the uh, analysis of the danger vegetations like this one in here. We can create we can go with this one also. Here is the tree growth analysis. So we can predict this how much time for the uh, tree growth for the to the danger points, and we can plan our groundworks according to that. And here we can analyze the danger points of the point cloud in here. We can analyze its danger points of the vegetation, then tree growth and tree growth warnings. We can set this much time of we have to uh, maintain the nest our lines maintenance, and also we can analyze the tree fall conditions. What are the trees can be fall into our power lines, and like this. Also, we can generate reports individually, same points, and we can get the locations for the our field works. Also, we have several tower inclination and nominal heights and other things in here. So here we previously I mentioned that we can extract all the features from here using the vector and semi-automatic way. We can manually digitize, and also it's very easy to digitize using the semi-automatic way. Um, we'll show the how to simulate, what are the tools for the simulations, and for this one. Think it's not detected any danger points according to our parameters. If we have any points, we can detect this with this one. And also, this is regarding the tree growth analysis, so we can um at the growth rate or according to these species of these trees, and we can analyze this how many years, also the growth rate, and we can start to analyze this one. Also, here's the we can use this one is point cloud, also the our vector data, and this is the simulations. Here we can simulation like yeah, here we have to select the tower type like extension. Sorry, straight straight towers, and then we can get, and then we can simulate according to the conditions and power line condition parameters. We can add the conditions, how much of the in this speed. Uh, Here, firstly, we want to add the scanning conditions when we are, what is the conditions when we are planning capture the data, and we can, yeah, here we want to add the vector file of the towers, and we can run these data set. First, we want to analyze the, sorry, digitize the our wires and other things. Then we can run this one. Okay. Also we can add seg analysis and other things in here. We can analyze the distance between the wires and shed lines, and yeah. In this way we can firstly we can create the all the data into vector, convert all the point cloud data into vector data by digitizing in the semi-automatic way or any other way. Then we can run simulations and all the things. Okay, we have several other very useful tools in here. So I think you can practice with these tools, and how to create the seg analysis from power lines and simulations also. Um, and yeah, I think that's the end of our session. And so if you have any questions, you can ask. Otherwise, we can stop, and you can give, give your question in the chat box also. Um, Otherwise, you can this is my contact details for if you have any question regarding this one, and or any other help need, you can get my reach my email address or my phone number. And thank you all for joining with us, and wish you all the best.
Thanks, Engineer Shalitha
Yeah,
and Engineer Thilosha. So it's like it was a great session, and like you took like the half day session like in online, which is tough, we know, and like you have retained most of our participants, which is like pretty helpful. It says the session was pretty helpful, and thanks a lot for being with us, and like probably we'll be connecting you with you all again. Thanks a lot and see you all soon. Thanks.
yeah, welcome.